Someone gave me some junk batteries, and I wanted to go through what I did to revive this pack and talk about balancing a little bit. Uh, so this pack is labeled as a 20 volt 4400 milliamp hour pack, but that is not the case at all. It's actually a 10 parallel 4 series pack with a bunch of 3000 milliamp hour cells in it. And I could vaguely see, yeah, like a barcode there, and don't know who made these cells. They've been scratched out, but then they have a rating. They're definitely life batteries, and they had a rating, yeah, 3000 milliamp hours. So that seems believable. So I got this pack. This is a pretty good size. These are 26 650s. So these are the bigger cells, and I got really lucky because basically the BMS was not turning on, and the output just protects the ground. This is both the charging and the discharge port, the way that this thing's wired. And anyway, the BMS was off, but this top set of cells were right at 2 volts. And so I was able to just kind of get my ground in here, and then it happened to be the end cell, so I could charge from here and bring these cells up somewhere close to where the other cells were, and then the BMS turned on and everything was good. So I did I did a few rounds of testing because my hope was that this balance, or the BMS, would actually balance the cell out, but it really can't. The only opportunity that it gets is when you reach end of charge. It will begin, it'll stop accepting a charge, and then it will bleed off the highest cell through these resistors, which are only going to bleed a tiny amount of power. So at that point, if you have a cell that's pretty low, like, it's just never going to catch up. You're never going to properly balance this pack through a BMS like this. What the BMS did do is protect the cells because they were at low cutoff, and so anyway, the pack appears fine. So I thought I would be all sneaky because I have this really weird active balancer, and this is just some crap I got off of eBay. And the way that this thing works is, rather than bleeding off at the top of your charge or offering any kind of protection, it simply redistributes charge between cells. And it's like a cheaper version of some of the packs that I've messed with before. Like, this is an active balancing system, so you don't see any big bleed off resistors here, and then these dudes are actually going to dump higher voltage to lower voltage cells and just keep the deltas close. And it does that throughout the discharge and charge cycle actively. So you're not throwing away as much juice, and theoretically you get a higher capacity because it's happening actively. But what I've found, I have 4 of these that have failed, by the way, and this is a more complex battery management system. And I'm still trying to bring them back to life. There's 2 that are talking but don't let me make it turn on. And I did find, yeah, I did diagnose one bad. That is a MOSFET, and I removed it, hoping that that, removing that short would make it better. But anyway, so I went looking for active balancers because I'm all about efficiency, and you can see some of the components in there. There you go. So that's what this active balancer looks like. And basically, for this pack and my planned usage for it, I just went ahead and wired this in parallel to see what would happen. And I don't think it's been particularly good. And in fact, my whole methodology for these type cells is changing. And that is because, depending on your use case, it's quite complex to determine state of charge of these lithium iron phosphate cells. And that's because they're weird. They have a cutoff voltage of 3.65 typically, but then they have a resting voltage of 3.3. And really the best method that I know of to get these in balance is to actually bottom balance them. So you're more likely to understand the state of charge towards the lower end of the charge, because it's such a flat discharge curve, and once it reaches the end of the charge, it begins to drop voltage very quickly, and that's when you know that your cells are depleted. And that's also when it's really important to cut them off. At any rate, the failure of this system is that this BMS didn't keep them in balance, and couldn't and can't. And as a result, we just had a cell that's low. So I bolted on this balancer, and the thing is that this can allegedly redistribute up to 3 amps between cells. So you would think that, that's awesome, but the reality is that I'm guessing, well, the specs on this is it only will actively balance when the cells are above 3 volts. And then if there's a difference of 10 millivolts, it will begin balancing. But there's not a lot of potential difference between, at 10 millivolts. So the amount of redistribution or charge that's available is kind of low. And at the end of the day, for all practicality, all I ever saw going between, cells being redistributed was around 100 milliamps, which, again, also depended on what these cells were doing. Like, your best chance of bringing up a lower cell with a higher cell is during a charge cycle, when a high cell is up near 3.6 volts and a cell that is low is, below 3.3 or 3.2. But the problem is when everybody's at 80%, or if you have, a few, 3 cells that are at 90 and 1 cell that is at 70, well, the voltage difference is really not enough. Again, it's like, it's a state of charge thing. So anyway, I did a bunch of testing, and here I can show you the methodology that I used here. Yeah, so basically I have this cool little wireless device, and it kind of looks like one of those DSP 5005s, but it's got this black box that connects to the battery system, and then you can configure all the low voltage cutoff and charge cutoffs, and basically you can protect or disconnect the pack based on whatever scenarios you set up in here. And then during charging or discharging, it is constantly measuring the amps and volts that it sees, and then calculating for you the amp hour that has passed via one direction or the other, as well as the watt hour calculations. So long story short, I took this pack, I topped it off best I could, you know, per cell. I didn't do a full charge cycle. I just kind of hooked it up to my lab power supply and got it, you know, got the low cell up to like, you know, 3.5 volts or whatever when it was near. I basically top balanced this pack, and that's not the best methodology, but and then here I hooked it up to a 2 ohm giant resistor, which you can see is 160C. And this is my little wise cam that was giving us this picture. And anyway, I did a discharge cycle and basically pulled about 75 watts on this pack until it was dead. And the first round, I got about 17 amp hours. And then I did a little bit of balancing again, and I was sort of checking what was going on with this active balancer, and you know, if it was doing anything, and it really wasn't. Again, I don't know if hooking these up in parallel is a super bad idea, because you know, the two boards could be interfering with each other, but this balance circuit has no protection circuit, so it's not monitoring low voltage, or it doesn't have the ability to disconnect the pack. So so anyway, I wired these in parallel. That's super horrible. But long story short, my plan after all of this is I believe this pack is a 40 amp hour pack. I've seen 25 amp hours out of it. It can discharge, you know, I think I can do 40 amps out of this BMS before it will remove the pack. So it does current limit, which is good. It protects you from direct shorts and things like that. And then it does a good job protecting against low voltage for cells by removing the pack. So I think what my plan is for this use case is I'm just going to wire up a charger like this, which basically charges through the parallel port, and that way I'm essentially going to be top balancing, but whenever I charge it, the pack will, each cell will reach its top voltage, and then I'm going to remove this silly balance port, and maybe I'll try this on a different group of cells, or maybe it would be better for lithium ion, and because they're a little more telling in their sort of depth of charge versus voltage. They have a little bit more of a linear discharge, and of course they don't have that weird charge voltage versus resting voltage, you know, that lithium iron phosphate has. But yeah, anyway, this is a pretty good pack, and I'm trying to figure out what I'm going to do with it. If I'm going to build like a, you know, I mean, I could do like a battery bank. I'm actually leaning towards hooking this up to some little panels that I have outside, and they're little baby panels, and having this run my shed, and possibly setting up a true Radio Shack, because I have a radio over there that I never use. Mostly because I don't have an antenna run, but also because I don't have power set up. You know, just whatever. I'm a bad ham. But I want this pack to do something somewhere. So I'm trying to decide what to do with it. I've also thought about making a portable boombox out of it, but that's not something I really need. So yeah, I'm thinking shed lighting, and let's see. I think that is not it. Let me see if I can get a picture of the panels that I plan on using here. Yep, there's my AC unit in my house that's dying. Oh, there's my backhoe. Come on, panels. Yeah, there you go. Look at those guys. So I'm pretty sure these are 60 watt, maybe in total. They're pretty old, but they're like essentially a 12 volt system. And I was using them to run this little experiment. Yeah, this guy, this is Rover 4.0. And really, this rover wasn't very good. And it was mainly, I was just trying to figure out how well the batteries were going to do. And these were lead acid batteries of some kind, and they really didn't survive. But of course, that guy could carry a ton of weight, but I didn't like that rover. So yeah, I think that's what I might do, is set up a Radio Shack. And I figured that I don't really, like, once this is balanced up, I probably won't have a lot of trouble with the amount of energy I need, you know, running lights in the shed, or I can throw a camera out there. I don't know. What would you guys do? What would you build? Then, oh, I did get some other junk. I was gonna make a YouTube on these. These look to me like quadricopter batteries from that well-known quadricopter that I can't think of the name right now. And I did, most of these were dead, but one of these dudes was kind of alive. And I did tear these apart, and it's actually pretty interesting. The battery management of these, let me grab the one that's kind of torn open here. Give me a sec. Yeah, so these dudes were kind of interesting, and kind of follow the design philosophy that I might see myself following. So this guy is alive to a degree. It's blinking here, and I'm guessing that's because one of these cells is completely screwed. But what I found is essentially what you have over here is a custom doodad, and all he's really doing is translating things from this chip, which we can try to get the numbers. I think that's a BQ3025 something, and yeah, BQ30Z55. So when I looked up that chip, essentially that is a battery management chip that is, I think it's speaking the SM bus protocol, and essentially this is a TI chip. And what that means, though, is more than likely for this pack, you could just ignore or chop these out. It's sending the data signals. You've got parallel, parallel pack voltage and ground, and then on the outside you have the data pins, I think is how this is wired, and it's the data pins to this guy. But if you hack those off and just grab the data pins from this guy, like, I haven't tried it yet, but it seems very likely you could just hook this up to I2C on a Raspberry Pi, and like I've done some Python in the past with that other pack over there, to get crap out of these. Basically speak SM bus, which is just protocol on top of I2C, and mostly. So yeah, I feel like this management system on its own might be useful, because it's pre-wired for a 4S pack, and you can just lop off and ignore this and just deal with this directly, and that at least should have enough info to give you insight in terms of state of charge, and allow you to turn on and off the MOSFETs, which should be, yeah, down there. So I mean, seems eminently hackable to me, but I haven't had time to mess with it. I only found the pinouts, and I think 2 of them ran to these little dudes, and one of them was like center pin, no connect right there. So just 3 wires, and I think you're in like Flynn. So that's something I wanted to try, but I need to find 4 good cells, I guess, because these are really powerful cells. You can just tell by the layout. They're fat and wide, and they got these big terminals. You know, you can just sort of tell by how fat and wide they are that these are meant to push a lot of amps. So if you have something that's meant to just suck a lot of amps until it's dry, these could be good. And then you can see like the size of these bleed off resistors, you know, a whole lot bigger than what we got going on in this big pack. Yeah. How's that work? 1 and then 1 0. So these are 100 ohm, and then these are 1 with no zeros, or 3 zeros. Are these 1K, or are these 1 ohm? Anyway, I'm getting off topic, but yeah, these looked pretty hackable. So that's something I might try to do, but I haven't had a lot of time. But I did want to just share some of the awesome junk I got from my friends at Central Battery, who are always giving me used up junk. And in this case, this is going to be a good pack. I don't know what I'm going to do with it, but it needs a job. And then this weird thing, I tried to find this thing again, and I can demo it, sort of give you an idea if I can find. Yeah, here it is. So the wireless end just needs USB. So we're hooked up now. It just doesn't have any signal, but this will actually speak to a bunch of different addresses. So you can go down here to address, and then target which address you want to speak to, and then it will display that that battery's information. And essentially this end is the programmable end, so all the settings and everything are there. And if I can find my cable, yeah, let's just grab a little jumper here. I also kind of blew this up. That was maybe the only fun part of the video that I made that I'm not posting, because it was like a couple days of me testing this pack, and I don't think anybody would be interested. But essentially, if you steal that and then hook it up not to the wrong place, this is meant to have external power. So I think we plug it up to plus. Yeah. Okay, and so it had a little delay, but you could hear hopefully the dude tick. And we'll just set this guy over here. But now we've got data, and essentially this is just really straightforward data. And I think it lost settings because it didn't have external power, so when the pack got cut off, all the settings got cut off. But you can basically see that you can set that's the charging amps that it will accept. So if it exceeds that, it will remove the pack. And here's an overcharge. One of these is discharge, one of these is charge. This looks like discharge, so 7.7 amps, which is, I only did that because that's roughly what my giant resistor was pulling. And then you have a low voltage cutoff, so it'll remove the pack there, and you can program this in, 1/10 intervals. And then over voltage protection, same deal. You can just have it remove the pack if the voltage ever does get too high. So this thing's great for like a lead acid string, and you can put 30 amps through it, no problem. This turns it on and off, so you can actually just manually turn the pack on and off. Clearing, I don't know. And then the battery here, you know, I'm guessing this is a 40 amp hour pack, but I just told it 34 amp hours, you know, and that way that essentially runs this thingy and lets you determine how much pack life is left, because you know, voltage doesn't necessarily tell you anything depending. And then here you can just set the range. Like we could just say, okay, it's a 34 amp hour pack, but we're at 80%. So it knows it's already discharged 6.8 amp hours. So, you know, it's a little clunky, but what you can do is tune this to be in line with what your actual tested results are. And then it actually becomes kind of useful. And set, oh, this determines at what state the system comes up in. So it's going to come up in an on state, and it's going to wait 2 seconds before it applies that state. Does that make sense? And I don't remember what this did. And I keep the display on forever. Yeah, and then the address, you could select a different address. You could be like, oh, come on. Yeah, you could be like, I want to speak to pack number 2. And of course that doesn't exist. What I don't know is how to change the address on this thing. I was looking a little bit, and like I refound these on eBay, and the search term, I'll put it in the description, sort of the search term to use, but looks like my power is slipping off. It seemed like all the newer ones, though, didn't measure through a shunt. Like this has a giant shunt in it. You can see also where I fried it. I fried that lead, hooking everything up wrong. I hit the wrong. There's a fried trace for you. But all the ones I saw on eBay, you know, these were in the $30 to $40 range. And same deal, they had a 30 amp dude, and they had the same or similar display and wireless, but they were no longer doing anything through a shunt. They were measuring through a coil. So, you know, essentially clamping the wire and doing all the measurements that way, which is probably, you know, probably better. But anyway, I'll find the search terms and use it. And then I don't know how the hell I set the address on this thing. I can't remember, and it's been a long time since I've opened this thing up, but if anybody's really interested in seeing it, I can open it up. But turned out to be a good dude to use in this test environment, except that it didn't hold the end milliamp hours once the test finished, you know. So you'll just have to trust me that I saw 27 amp hours on the clock before it shut off and then was dead. Anyway, that's it. Playing with junk, playing with batteries. Don't know if this will help anyone, but thanks for watching, I guess.